The Department of Highways is the main agency that oversees the highway network throughout the country. Currently, the Department of Highways has almost 78,000 two-lane kilometer routes, consisting of approximately 70,000 kilometers of asphalt surface and around 7,600 kilometers of concrete surface, and only 62 kilometers of unpaved surface. The Department of Highways takes into account the convenience and safety of road users. To be more precise, we focus on the smoothness of roads because it plays a significant factor in making road users convenient and safe. The International Roughness Index (IRI) is an index used to determine the roughness of the road surface. It can indicate the overall surface condition of the pavement from the results of the total vertical level change divided by the total horizontal distance while driving. The IRI are very well known and used by many countries in pavement management and is also acknowledged by the World Bank. Generally, IRI for newly constructed roads range from 1.5 to 3.5 meters per kilometer. The acceptable IRI requirements, however, vary from countries to countries. It depends on the policymakers and the budgetary allocation for road infrastructure. As for Thailand, the Department of Highways requires the newly constructed roads to have the IRI not greater than 2 meters per kilometer for asphalt pavement, and not greater than 2.5 meters per kilometer for concrete pavement. In order to measure IRI, an accurate and efficient instrument is required for such mission. Fortunately, the high-tech device like laser profiler is brought to inspect roads, which help us overcome former issues such as time-consuming inspection. Since 1993, the Bureau of Materials Analysis and Inspection has utilized equipment such as the bump integrator and deep state profiler for surveying road roughness. The Class 1 laser profiler had just been invented in 2011 and has been widely used by the Bureau since then. The latest pavement surveying device developed in 2021 is from the Australian company IRI. The Hawkeye 2000S series, which is a Class 1 laser profiler, is installed on a 4-wheel drive small truck, able to meet the needs of the Department of Highways effectively. The vehicle used to survey and analyze asphalt and concrete roads can record damage data on the pavement. It collects data for analysis using a laser profiler to measure pavement roughness in terms of the International Roughness Index (IRI), according to the American Society for Testing Material Standards (ASTM), the professional association of science and technology that defines and establishes standards globally, namely ASTM E950, ASTM 1845, ASTM E1703. The laser bar installed at the front of the car consists of an accelerometer and a laser, the Class 1 monitoring device with a beam size less than 1 mm. This device will shoot a beam of light onto the pavement to collect IRI, rating, and MPD data. This time measurement instrument mounted on the side of the rear view is used to measure speed and distance with a resolution of 2000 pulses per revolution and an error of 0.1% depending on temperature and thermal expansion. There is a beam mounted on the top of the car's loop for a GPS receiver and a high-resolution rear camera to capture pavement failures such as cracks, potholes, etc. Furthermore, a front camera is set in the front of the vehicle for capturing high-resolution images of assets such as traffic signs, electric poles, milestones, and so on. The control cabinet is the device controlling the operation of the Hawk R2000S system. It collects data from each device to display the values via the program. Gypsy track consists of two receivers used to receive signals for geocoding along the loop surveys. It can also collect orthogeographic information such as gradient, crossfall, and lattice of curvature of the loop. When the laser heads through the beam of light to collect data, the cameras will capture images at every specified distance. Then, the data will be sent to the control cabinet for processing and then being displayed on the screen. According to STM E950, IRI data collection is a measurement and data acquisition standard using two Class 1 lasers in combination with a wheel-mounted accelerometer. With STM1845, MPD data collection must have a laser beam size of no more than 1 mm, and survey data is collected every 1 mm by collecting data in a distance of 100 mm. The obtained values are then divided into two intervals, and the peak value is taken into account in the formula, which will provide MPD value. According to STM E1703, lighting data collection is a data collection from using the lasers. The obtained values from each laser were calculated to get the lighting values of the left view path and the right view path. Low geometry measurements are processed by the Hawk R2000S system equipped with Gypsy track that measures low geometry data, namely gradient, crossfall, radius of curvature, and vertical curvature of the loop, which will work as follows. Firstly, gradient. The system measures the change in inertia from the 3-axis accelerometer in combination with a distance measuring device or DMR to convert it into a change in angle or percentage so that it can indicate how steep the load is at that point. When the front of the vehicle is higher than the back, like a car going uphill, it will show a positive value. If the front of the vehicle is lower than the rear like a car going downhill, it will show a negative value. The unit of gradient is in degree or percentage, depending on the measurement unit selected. Secondly, class 4. The system measures the inertial changes from the 3-axis accelerometer in combination with running direction measurements for the 3-axis angular velocity device to convert it into a change in angle or percentage. For example, when a vehicle tilts to the right, so the left side of the vehicle is higher than the right, it will show a positive value. On the other hand, if the car tilts to the left, it will show a negative value as shown in the picture. The unit of cloth slurp is in degree or percentage depending on the measurement unit selected. Thirdly, radius of curvature. The system measures the rate of change in landing direction with the 3-axis angular velocity device to calculate the radius of curvature in meters. To illustrate, when the road curves to the right, it will show a positive value. Conversely, if the road curves to the left, it will show a negative value as shown in the figure. And the last one, vertical curvature. The system measures the rate of change in road slope values with the 3-axis accelerometer in combination with DMR to determine the rate of change in vertical curvature. As for the unit of this, it's shown as a percentage per distance. When the road has an upturn curve, it will show a positive value. And when the road has an inverted curve, it will show a negative value, as shown in the figure. To create safety for road users, the Department of Highways has a crucial duty to inspect newly constructed roads with the testing tools that meet the international standards like these technologies, and make sure that contractors construct pavements according to their standards so that the roads of Thailand will last longer and greatly reduce road maintenance.